All right.
Good afternoon. My name is Anthony Smith. This is my colleague.
Ebony Stallworth.
And we're doing our presentation on how to make cornflakes. So, we're doing it on cereal, where we cut it down to cold cereal, which is the cornflakes. And how many like cereal? What's your favorite cereal? I mean, like cereal, right? I would like nobody like cereal. All right. Basically, breakfast cereal is a processed food manufactured from grains and intended to be eaten. A main course is served with milk in the morning meal. It's the most popular, and vitamins and minerals are often added to the breakfast cereal to reduce the loss. During cooking, the most important of these is vitamin B1, which is 90%, which is destroyed by heating in the cooking process of cooking the cornflakes. The antioxidants of BHA and BHT are preserved and most often added to the breakfast cereal to prevent from becoming stale or rancid. A little bit of nutritional facts about cornflakes. Are low in protein, but high in carbohydrates. The most important raw material is grains. Cornflakes contains no fats or no saturated fats. It's cholesterol free. And also by adding a half a cup of skim milk, it's marvelous a snack or a great diet. Its water activity is from 0.3 to 0.5. Its moisture content is between 12 and 14%. Microbiology behind it. Microorganisms that contain cereal grains may come from air, dust, soil, water, insects, rodents, birds, humans, storage, shipping containers, and handling and processing food. The microflora of the cereal and the cereal products is verified and includes mold, yeast, bacteria, Psychotrophilis, Mesophilus, thermophilus, lactic acid, bacteria pathogens, coliforms, and and continuous is bacteria are frequent surface contaminants of cereal grains. Bacteria can grow in cereal grains, will require a high moisture content of the water activity in equilibrium and high relative humidity. Generally, bacteria are not significantly involved in the spoilage of the dry grain. It becomes a spoilage factor only after extensive deterioration of the grain has occurred at high moisture content. One of the toxins in it is mycotoxins. They are a chemical produced by fungi species that pollinates crops and fields after harvest. Producing the fungi grow on sample or raw materials. Unfortunately, it's difficult to prevent mycotoxins in production for harvest, storage, or during process. And there are some strategies being made to prevent mycotoxins. When making the cornflake, we have maybe browning, which is toasting the browning of food that are rich in products, and which contains a mixture of for reducing sugars and amino acids and subject to heat treatments, and that's the nigger brown.
Alright, so I had the processing portion. And in looking at the processing, I could have chosen the conventional method or the extruder method, and I chose to use the extruder method because in most places you'll see it done this way because it's more economical. And the processing parameters include the cooking for 1 minute at 150 degrees Celsius, and then it's taken through a vacuum where the vacuum removes moisture and it takes the moisture content down to 18%. And then from there you'll have a cooling at 95 degrees, and then pelletizing. And during the pelletizing, it ensures that you have a uniform product before flaking. Here, this is the second step in processing, where it's taken to a flaking mill. And as you can see, the first image shows you an example of a flaking mill where you have metal rollers that roll together as the product is going through, and flakes come out at the end. And then it's taken through a toaster, and it's taken down to 3% moisture. And inside the toaster is where you'll have that Maillard browning reaction from the maltose that was added in as one of the raw materials, because maltose is a reducing sugar and it'll react with the amino acids from the protein in the corn. And then from there you'll go to the enrobing, and this is a typical example of an enrobing machine where you have nozzles that spray on additives such as sugar for frosted flakes or vitamins and minerals of that nature, because during the extrusion process you will lose a lot of the vitamin content in the food. And then from there it's taken to a cooler where it cools down to 30 to 40 degrees Celsius, and then from there it's taken to packaging. And here are some common types of extruders. You'll have a single screw where you'll have the top arrow there where you're pouring your raw materials in. And then you'll have a screw that's turning, and as it's turning, the solids come in, and then heat and high pressure are added, and everything is melted down. And during that melting process, that's where you'll get the breaking of the starch granules inside of the corn, and it'll form a gel, which is thermo-irreversible. And then at the bottom here is an example of a double screw. And those can be counter-rotating or co-rotating. And in this example that I have here is co-rotating, meaning that the screws are rotating in the same direction. Well, we're having some technical difficulties, but we actually pulled up a video to show the entire process from beginning to end of making the cereal. Bear with us. And as I stated before, during processing, some of the chemical changes that occur is gelatinization of the starch. And then you have protein and extrin during the extrusion method because of the heat. And that'll allow for that Maillard browning to take place, which is non-enzymatic browning. And the grains are not disrupted during the cooking process, and that's because the temperature is not high enough, and that's how you get whole grain cereal. And then from the extruder, the high shear and the low moisture will degrade the starch extensively. And here are some packaging materials when you packaging and you're done, you have your finished product. They use fiberboard boxes, and they use supercalendered wax wrapping, and they vacuum seal them under nitrogen because the oxygen can cause oxidation, and it'll cause all flavors inside of your cereal. And also, these type of packaging protect from light, moisture, and oxygen, which can attribute to that rancidity and the off flavors and loss of sensory attributes. Any questions?